Hi, I'm Chirag and I want to show you something that I've been building called Kage. So, Kage is a local first personal AI broker. The idea is simple. Every tool you use today starts from scratch. No memory of who you are, what you're working on, what you decided last week. So, Kage sits between you and all of those tools as a second layer, a shadow layer that holds your context, your memory, and your identity and routes it to the right place at the right time. Now, for this capstone, I built three agents on top of Kage that form a self contained multi agent pipeline, as you can see on the screen. So, Scout is a proactive agent, runs independently. Let me show you the system live. So, let me just check the status of currently. So, as you can see, it has 158 nodes across 7 projects, all stored as local markdown files. 3 arms connected: calendar, Gmail, and browser, all read only, all running through macOS native APIs and zero OAuth. So the three agents, Scout, Librarian, Monitor, all feed into the same memory store. Let me walk you through each of them. Scout report generated last night. So Scout is a two-stage ADK pipeline. Stage 1 runs entirely or locally on Quen 3. It pulls from 5 sources: Hacker News, Archive, GitHub Trending, Reddit, and RSS feeds, and shortlists the most relevant items for my active project. Stage 2 sends those shortlisted items to Claude, which integrates them into this structured morning report. This, as I said earlier, is my last night report. Every item has a source, a tech relevance summary, a Kage relevance note explaining specifically why it matters to what I'm building, and a cycle candidate flag it should influence the next development cycle. Scout also maintains a scene cache. It will never surface the same item twice. And because stage 1 runs locally, the heavy lifting, that is fetching, filtering, deduplication, never touches cloud. So cloud only sees what's already been shortlisted. This way we also manage token consumption. Now let me show you what's in the librarian queue. Output doesn't go straight into memory. That's librarian's job. Librarian is deliberate. Every scout find lands in a staging queue first. Librarian is an ADK LlmAgent with 10 tools. When it runs, it checks for duplicates against existing memory using FTS5 full text search, runs each item through the privacy gate, and surfaces it here for my approval. 6 items waiting right now. Each one shows the title and reason it was flagged, which agent sourced it, and exact commands to approve or reject. Notice the last one, source is monitor and not scout, which that's the monitor to librarian pipeline, which I'll show you in a moment. Let me just approve one of this and show you how it works. So we have given the command and it's written, approved and written. Item is written to permanent memory as a markdown file embedded into ChromaDB for vector search, injected as a few short example for future librarian decision. Librarian literally gets better at judging based on what I've approved before. That's the CTM learning loop. The more I use it, the better it gets at matching my taste. Now let me just show you what was the last monitor status. Monitor is the third agent. It watches the machine itself. It runs 2 jobs via launch and observe daemon polls every 5 minutes using macOS accessibility APIs, capturing which app I'm in, what window is focused, how long I've been idle, what text is on screen. At 7 a.m. every morning, it runs a digest, a cloud pass that synthesizes everything it observed overnight into this briefing. This morning it noticed that I have been in anti-gravity most of the day. It flagged a librarian queue backlog. It called calendar MCP timeouts. These are real observations from real machine state. Now monitor deposits its digest directly into librarian staging queue. your machine's own activity becomes part of your permanent memory. The reason why monitor is important is it can also give context to help improve the system itself. So it knows what I'm currently working on, what window it's open. So while giving prompts to my local model, it access those small signals and writes better prompts. Now let me show you gate.py. Yeah, so everything I've shown you, scout, librarian, monitor, runs through this, the two pass gate. Pass 1 is silent, hard blocks, local only nodes, never leaves the machine under any circumstance. Identity walls are enforced. My personal context cannot bleed into school or work context. So pass 2 is a reversible PIR masking. Before anything reaches clouds, names, emails, phone numbers are replaced with anonymous tokens. The model answers with those tokens in place. Kage swaps the real values back before you ever see the response. The reason is that we don't want any context to be lost, but we also don't want to share any important information. So this is wired into every single outbound call in the system. Scouts, cloud stage, librarians judge pass, monitors digest, repel, all of them. It's not an add-on. Now let me show you my MCP servers. So Kage also ships as an MCP server with 4 tools: recall, remember, ask, and status. You can see it registered here in anti-gravity. Kage recall is read-only project scope. It only returns what's relevant to your current context, filtered by identity and project partition. Kage remember is write gated by default. Nothing writes to your memory without explicit permission configured in your config file. Read-only identities cannot write at all. So Kage ask routes your question through Kage's full stack retrieval, privacy gate, model routing, and returns a grounded answer. Any MCP compatible client connects this way. Kage becomes the memory layer underneath every AI tool you use without any of those tools needing to know anything about each other. 29 ship cycles, 6 Kaggle concepts, multi-agent ADK, MCP server, security gate, anti-gravity, deployability, agent skills, etc. All covered in production code, not demos. Kage is the shadow, invisible infrastructure that makes every AI tool you use already a little smarter, a little more aware of who you are and what you're working on. So the full code is on GitHub. The link will be in description. Thank you.